Hey, Austin, can you come help me with this calculus problem here? I'm stuck.
Yeah, no problem. What we got here? Alright, 2014 AP Calculus free response, number 1. Classic.
Yeah, it's a doozy. So the problem is that there's grass clippings are placed in a bin where they decompose, and for the interval 0 to 30, the amount of grass clippings remaining in the bin is modeled by A of t equals 6.687 times 0.931 to the t power, where A of t is measured in pounds and t is measured in days.
Alright. I think I can help you with this.
Good.
Alright, so if you look at A here, it says find the average rate of change over the interval 0 to 30, indicate the unit of measure. Well, if you look at this from a conceptual point of view, then it's asking to find the AROC or the slope over the interval.
Okay.
Alright, let me go grab something right quick.
Alright.
Alright, so A, we're going to start with our 2 endpoints. Then we're going to do the classic y2 minus y1 over x2 minus x1. And that's going to equal negative 0.197 pounds dead.
Okay.
Alright, Mike, so what's B asking?
Well, let's see. B says that we need to find the value of A prime 15, and using correct units, we need to interpret the meaning of the value in the context of the problem.
Alright, so the concept of this problem is we have to find the IROC, or the instant rate of change, when time equals 15.
Okay.
You don't want to toss that in your calculator. Alright, Mike, so do you have the equation for the problem and y equals 1?
Yes, I do.
Alright, so now we're going to go ahead and hit math 8.
Math 8.
Go ahead and hit d over dx. And go ahead and hit y1. There you go. And then you're going to do x equals 15. And if you do it right, you should get negative 1.64 once you round.
Alright.
Alright, Mike, so what's he asking?
She's asking to find time t for which the amount of grass clippings in the bin is equal to the average amount of grass clippings in the bin over the interval 0 to 30 days.
Alright, so the concept for this problem is we have to find the average of the area under the curve.
Okay.
So we're going to do this by first integrating the equation and then dividing it by 30. And once we get that number, we're going to find where that intersects the original equation.
Oh,
to get our time. So what we're going to do is we're going to start by hitting 1 over 30. Then you go math 9. It's your integral. Then you go
5. Yeah, put 0 to 30 days, right?
Yep. Then you go ahead and hit your equation, y1.
Okay.
dx. Then enter. Got it. Alright, so once you got your 2.753, we're going to take that and we're going to toss that right into y2. There you go. Oh, one step ahead of the game. Now what we're going to do is we're going to go to the graph and we're going to find where that intersects. Go ahead and calculate intersects. And alright, so you got your intersection? Alright, so what does it say?
It says 12.41292.
Alright, there we go. Nice answer. Alright, so what's D saying, Mike?
D says that for t greater than 30, L of t, which is the linear approximation to A at t equals 30, is a better model for the amount of grass clippings remaining in the bin. And we need to use L of t to predict the time at which there will be 0.5 pounds of grass clippings remaining in the bin. And we need to show the work that leads to our answer.
Alright, so the concept for this problem is going to be linear approximation.
Okay.
Alright, so for this, Mike, we're going to be using the point slope formula, which is y2 minus y1 equals mx minus x2 minus x1. Alright, so now we're going to sub in the values that we already have, and we're going to have to solve for x2 for in this problem t. Alright, so Mike, if you're gonna toss that in your calculator and solve for t, we're gonna get t equals 35.054 days.
Oh, yep.
Awesome. Alright, so Mike, you know what you're doing now?
Yeah, I think so.
Alright. Have a good one, Mike.
Thank you, Austin.
No problem, G.
Oh, wait, Austin.
Yeah,
Calculus rocks.
totally did.